All right, so the answers to number 17 should be this one, I believe, has 2 lines of symmetry. This one is only going to have 1 line of symmetry. It'll be right down the middle. This one will have one here, one here. This one's going to have 4 lines of symmetry. So this will be answer C. It'll be from midpoint to midpoint, midpoint to midpoint, then vertex to vertex, and then vertex to vertex. And then the circle is going to have infinite many because what do we call it when we divide a circle in half? It's a diameter. So how many diameters does a circle have? It has infinite many. I can't draw them all. All right, so this one has infinite many circles. Infinite many lines of symmetry. Explain why BD is not a line of symmetry. Well, it does not cut this into 2 equal pieces. Does triangle ABC have any lines of symmetry? It does not. And it appears that this is a scalene triangle. And for a triangle, you have to have at least 2 sides to be the same length in order to have a line of symmetry. I just want to make sure D is on AC, BD is perpendicular. That just makes it right to AC. So no, it's not going to have any. Let me jump over here to show you the answers. Okay, so there are the answers, the drawings to number 20. It said to also identify the line of reflection. So you can see over here, the line of reflection is x equals 4. I can draw it right here. Here's the x equals 4 line. And then the other one is the x equals -1. So there's the other line of reflection. That reflects these two. And then the other one is y equals 0, which is the x-axis. And that reflects these. Okay, number 21 says, describe a reflection that would map the arrow onto itself. Oh yeah, if you cut it right down the middle. Cut it right down the middle right there, then this side would reflect over to that side. Number 22 is a multiple choice question, I believe. Oh, no, it's not. It's asking you for a point. And the question was, answer is point D. 23, does any point remain fixed? Yep, it would be point A because it's on the line of reflection. And which sides of the pentagon are congruent? So ED is going to be congruent to BC. ED is going to be congruent to BC, and AE is going to be congruent to AB. And that's it for that one. I did promise you the answers to this one. So I'm going to scroll here. Maybe I can make this a little bit bigger so you can see the answers. You got 1 line of symmetry, no lines of symmetry, 1 line of symmetry, 1 line of symmetry, no lines of symmetry. Well, she looks like exactly the same. No, she doesn't. Her hair right here is a little over to the side. So since it's not right smack dab in the middle, she doesn't have a line of symmetry. Goodness gracious, this one over here has a bunch. Vertex to vertex, midpoint to midpoint. This is a hexagon, so it has 1, 2, 3, 4, 5, 6, 7. No, 6. 1, 2, 3, 4, 5, 6. It has 6 lines of symmetry. You got a nice little weird shape over here. The triangles have a line of symmetry, and then the circle that doesn't pass through the triangles do. So anyway, another thing that you might want to take a look at are the letters of the alphabet, because a lot of times they'll ask questions about the letters of the alphabet, which ones have lines of symmetry, and playing cards. So, like a deck of cards, look at the ace of diamonds. Does it have a line of symmetry? Look at the eight of diamonds. Does it have a line of symmetry? Those kind of things. They ask those questions too. So, okay, that should finish up the 9-3, the lesson on reflections and lines of symmetry.